Today, we're going to pull back the curtain on the digital world and look at the invisible architecture that powers pretty much everything you do online. We're talking about databases.
I mean, have you ever thought about it? You add a laptop to your online cart, you get distracted, close the browser, and then 2 days later you come back, and it's still there. How in the world does that happen? How does any website remember you?
Well, the magic behind it all is a database. And no, it's not just some giant clunky spreadsheet. It's a super organized system built for incredible speed and reliability. It really is the brains behind the screen. Okay, let's dive into how it all works.
So, before you can store a single piece of information, you need a plan. I mean, you wouldn't build a house without a blueprint, right? You'd end up with a mess. The same exact thing is true for a database. This planning phase is absolutely crucial.
The very first step in making our blueprint is figuring out the main things we need to keep track of. In the database world, we call these entities. So for our online store, the big ones are pretty obvious. You've got customers, the products they buy, and the orders they create.
Okay, so once we know what we're tracking, we have to ask, what do we need to know about them? These little details are called attributes. So for a product, we'd want to know its name, its price, and maybe how many we have in stock. For a customer, we'd need their name, email, you get the idea. These are the actual fields where we'll store the information.
Now here's where it gets really powerful. These entities, they don't just exist in their own little bubbles. They're all connected. A customer places an order contains products. We call these connections relationships, and this is what makes a database so incredibly smart. Think about it. A customer moves and changes their address. You only have to update it in one place, and instantly every single order they've ever made is linked to that new correct address. That's the power of an interconnected system.
So it really just boils down to this simple three-step process. First, you find your main objects, the entities. Then you describe them with all the key details, the attributes. And finally, you link them all together, the relationships. That's really the heart of good database design.
And this right here is what that blueprint actually looks like. It's called an Entity Relationship Diagram, or ERD for short. You can see how each box is an entity, like customer or order, and those lines between them, those are the relationships we were just talking about. This map lets us see how everything fits together before we even think about writing a single line of code. With this in hand, we're ready to start building.
Okay, so our blueprint is ready. Now we need the tools, and more importantly, the language to actually build our digital store and bring this whole thing to life.
And that universal language is SQL. It stands for Structured Query Language. For decades now, it's been the gold standard for talking to databases. It doesn't matter if you want to create something, add data to it, or ask a really complex question. You're going to be speaking SQL.
And believe me, it is powerful. It's the whole toolkit. You use it to build the tables, put the data in, change it later, and even take it out. But most importantly, it lets you ask incredibly specific questions, like, hey, show me every single laptop we sold last week. That's the part we all experience every single day.
Now, SQL commands are usually broken up into a couple of different groups. The first one we're going to look at is called DDL, which is short for Data Definition Language. This is the part of SQL you use to actually build the structure of the database itself.
Yeah, you can think of DDL as the construction crew. And the most fundamental command, the one it all starts with, is create table. This command takes our blueprint and builds the empty containers, the digital shelves that are going to hold all our data.
And here's what that looks like in the real world. Check out the command on the left. We're saying create table students, and then in the parentheses, we define our columns and what kind of data they'll hold. And the result, over on the right, a perfect empty digital shelf, all set up and ready for us to start stocking.
Okay, our shelves are built. Now we actually need to stock them and manage all our inventory. For that, we turn to the next set of SQL commands, DML, or Data Manipulation Language. So the very first thing we need to do is get some data in there. The insert into command is how we do it. This lets us take a piece of information, like a brand new product, and place it right onto the correct shelf.
So after running that insert command, our products table isn't empty anymore. Bam! We now have our very first record, a laptop, with an ID and a price. The data is officially in the system.
But, data rarely just sits there. Things change. What if we need to put that laptop on sale? We use the update command. Now look closely, because that where part at the end, that is the single most important piece of this command. It is your safety net. Without it, you would accidentally change the price of every single product in your store. It's what stops a simple price change from becoming a total disaster.
And there's our result. The update command found that one specific product with the right ID and changed only its price. And just like that, our data is current and accurate.
Finally, what about getting rid of data? Well, SQL gives us a couple options, and it's really important to know the difference. Delete is like a surgeon's scalpel. You use that where clause to remove very specific rows, and often you can undo it. Truncate, on the other hand, that's a wrecking ball. It removes all the rows from a table instantly. It's way faster, but there's usually no going back.
So we've covered a lot, from abstract ideas to actual code. Let's zoom back out for a second and tie it all together, because this stuff is so fundamental to our digital lives.
So let's bring it all home. The first big takeaway is this. A good blueprint is what turns a chaotic mess of data into organized, reliable information. Second, a universal language like SQL gives us the actual tools to build and manage that structure with precision. And third, when you put them together, well, you get the invisible foundation for everything from your social media feed to global banking.
It's this hidden logic that just works. So the next time you're browsing an online store, or you check your order history, or you see a personalized recommendation pop up, just take a second. See if you can spot the entities, the attributes, and the relationships working tirelessly behind the scenes. Thanks for watching.